Alright, hello everyone. Me again, February 27th. I just finished one, which is solving the problem from yesterday. I used the time travel to maintain my streak. Um, it's all because a little bit mass miscalculation. I went to collect some data today, and by the time I realized I want to do it, it's a little bit kind of too late. I think it's around 4 o'clock, 4 p.m. And data collection will last 3 hours from the moment I left to the moment I came back. 3 hours. So I kind of knew it was impossible. I tried to see, okay, is it possible for me to do it really quick so I can be back by 6:30 so I can solve at least the problem for today without having to use the time travel. But it's not possible. So I might as well just use the time travel. It's not the first time I use the time travel, so it's okay. And then we solved number 460, which is the LFU cache. It was quite complicated. As I left a commentary in my previous video. That is, 460 is not difficult, especially if you have solved LRU cache and know the trick with the double linked list. But it's complicated because it's a combination of quite a lot of parts. If we put a lot of parts together, there is W linked list. It's a dictionary of W linked lists, and the key is the frequency. And I didn't figure out how to find the minimum frequency in the O1, so the ones I submitted it's OM, right, to find the minimum frequency. But like I said, if you're not intentionally trying to create a test case where there are just a long list of frequencies, the length of the frequency won't grow too big. But the genius of the solution that I just read was that it is possible to maintain the minimum frequency in O1 um, complexity. The reason is, right, hear me out. So when we do a get, right, we need to remove a node and remove the node from the previous frequency and put it into a new frequency. So there is a change of frequency there. But if I remove the frequency and the original frequency, there's still things left. That means overall, the grand scheme of things, the minimum frequency won't change, right? Like if I move the code from a frequency of 3 nodes, and then the frequency will have 2 nodes, so that frequency still exists, so we don't have to change the minimum frequency. Now, if the frequency where I remove the node, after the removal, it becomes zero. There's a zero length in that double linked list. Now we have to check if that frequency is the same as the minimum frequency. If it's not, then we don't care, right? We don't care. So the minimum frequency still exists somewhere, so we don't have to make any changes. We only need to change the minimum frequency if the the frequency where the node has just been removed is the same as the minimum frequency. But you would say, okay, if I remove that frequency, what is the next frequency? How do you know that? Well, we do, because in this process, when we remove a node, we'll put the node into a new frequency linked list with a frequency just plus one, right? So we know the original frequency plus one will always exist after this operation. So the minimum frequency, if it's equal to the previous frequency, which is now gone, then the new minimum frequency must be the previous one plus one. That's it. Perfect. And then looking into the put operation, right? So the put operation, again, if the node already exists, because the way we write it, we will call the get first, and then we will go through that frequency change already, so we don't have to worry about it. So when we have to add a new one, now that is something very interesting. When we have to add a new one, it is guaranteed that the minimum frequency will be 1. This is the new one added in that has frequency of 1. So this tells us no matter what, the minimum frequency is none. It's always kept in O1. So that's really brilliant. All right, so let's do this is today. No, this is for tomorrow. For tomorrow, and I have another hard question here that I haven't resolved yet, but I don't want to do it today. I'm a bit tired, so let's just crank this out and call it a day. Now we've done this already. All right, summary ranges. You're given a sorted unique integer array. return the smallest sorted list of ranges that cover all the numbers in the exact. Each element of a number is covered by exactly one range, and there is no integer x such that x is in one of the ranges but not in nums. Each range a to b in the list shall be output in this. Okay. So 0 to 2, 4 to 5, and 7. 0, 2 to 4, 6, 8 to 9. Yeah, because it is required that each element in number is covered by exactly one range, and there's no integer x such that x is in one of the ranges but not in nums, which means if I have gaps, then the range can never cross the gap, right? Because if I cross the gap, then there will be a number in the range, but it's not in the nums. Therefore, if there's no gap in the range, it has to be consecutive. So the question turns into finding the consecutive values, and whenever there's a gap, we will put this up, we'll get a new one, right? And then with a gap, put a new one. And if it ends, or if I have two gaps, so have a gap, have another gap, then yeah, that'll be it. Okay. And it is an easy question, so nothing to, oh, hold on. What do we do now? ST. No. We'll copy first. And then we do ST. Oh. Yeah, we'll probably resolve this tomorrow. Okay, so what do? We have a result. It's going to be this. So I in range 1 to len nums. Okay. Always num 0. We say if nums I is not equal to if it's not equal to what? If it's not equal to nums I minus 1, right? Then we say nums I minus 1 need to be, and then we say res minus 1 shall equal to f this if yeah, I just realized it would be easier I just do this. If nums I minus 1 is not equal to res minus 1, right? Else, then simply str res minus 1. And here is going to be res minus 1 to nums I minus 1. If it's not equal, then we do this, and after we do this, res need to dot append nums I. If it's equal, just skip, and the last one. So if the last one is equal to, then we have to handle it. If the last one is not equal to the previous one. Then the previous one, and then anyway, all right. Anyway, we'll have to do this one more time to handle the last node. This equals this with nums. Oh, this won't be nums I minus 1, it will just be nums I. Right? Just be nums I. If nums I is not equal to, otherwise it will just be this. Okay, let's try this. They're like very complicated. Okay, so what test case do we have? This is actually a good contest problem. Lately, I feel like the easy one in the contest is sometimes it's too easy. I'm not sure if that's a fair sound. What the hell? Huh. Oh, for one thing, I shouldn't have the space. That's very interesting. I put 0. And then, oh, +1. My bad. Ugh. Screw you, I forgot about this. Madre mia. Could be empty. Where? Oh, so nums answer. Wait, do I answer this one? This one, right? Forgot. So if land nums, right, if not land nums, return this. Didn't check the edge case. Bad. Eh? What? Oh my god. Reference before assignment. Oh, shoot. Huh. Alright. That's stupid. Two errors. Just not careful. Now one more, I'm gonna lose my mind. Got about 2 edge cases where num is equals this or this. Causes me that caused me 2 errors. How can I be this callous? As a previous attempt. I can use join. It's true. I did the ranges, which is fine. Okay. All right, I don't want to do another one, so let's just call it. Let's call it a day. I'll see you guys tomorrow night, and I think tomorrow night is still easy, so we can probably handle this minimum time to final to finish a race.